Yes, welcome back. I'm back from bathroom. The video was just to split, so I think I did like to stop the video. But I think I should download this electric motors and this Hank Christian Ørsted. He's a Danish from my country. Probably I should read about him. But let's just continue.
A basic electric circuit. The voltage source V on the left drives a current E around the circuit. Delivering electrical energy into the resistor R dot from the resistor. The current returns to the source. Completing the circuit. The inductor is a conductor, usually a coil of wire, that stores energy in a magnetic field in response to the current through it. When the current changes, the magnetic field does too, inducing a voltage between the ends of the conductor. The induced voltage is proportional to the time rate of change of the current. The constant half proportionality is termed the inductance. The unit of inductance is the Henry, named after Joseph Henry, a contemporary of Faraday. 1 Henry is the inductance that will induce a potential difference of 1 volt if the current through it changes at a rate of 1 ampere per second. The inductor's behavior is in some regards converse to that of the capacitor. It will freely allow an unchanging current, but opposes a rapidly changing one. 62, 226-29 Electric power. Electric power is the rate at which electric energy is transferred by an electric circuit. The SI unit of power is the watt, 1 joule per second. Electric power, like mechanical power, is the rate of doing work, measured in watts, and represented by θP. The term wattage is used colloquially to mean electric power in watts. The electric power in watts produced by an electric current I consisting of a charge of q coulombs every t seconds passing through an electric potential, voltage, difference of Vi where q is electric charge in coulombs is time in seconds, I is electric current in amperes, V is electric potential or voltage in volts. Electricity generation is often done by a process of converting mechanical energy to electricity. Devices such as steam turbines or gas turbines are involved in the production of the mechanical energy, which is passed on to electric generators which produce the electricity. Electricity can also be supplied by chemical sources such as electric batteries or by other means from a wide variety of sources of energy. Electric power is generally supplied to businesses and homes by the electric power industry. Electricity is usually sold with kilowatt-hour, 3.6 mJ, which is the product of power in kilowatts multiplied by running time in hours. Electric utilities measure power using electricity meters, which keep a running total of the electric energy delivered to a customer. Unlike fossil fuels, electricity is a low-entropy form of energy and can be converted into motion or many other forms of energy with high efficiency. 63. Electronics. Electronics deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes, optoelectronics, sensors and integrated circuits, and associated passive interconnection technologies. The nonlinear behavior of active components and their ability to control electron flows makes amplification of weak signals possible, and electronics is widely used in information processing, telecommunications, and signal processing. The ability of electronic devices to act as switches makes digital surface mount electronic components information processing possible. Interconnection technologies such as circuit boards, electronics packaging technology, and other varied forms of communication infrastructure complete circuit functionality and transform the mixed components into a regular air working system. Today, most electronic devices use semiconductor components to perform electron control. The study of semiconductor devices and related technology is considered a branch of solid-state physics, whereas the design and construction of electronic circuits to solve practical problems come under electronics engineering. Electromagnetic wave. Faraday's and Ampere's work showed that a time-varying magnetic field acted as a source of an electric field, and a time-varying electric field was a source of a magnetic field. Thus, when either field is changing in time, then a field of the other is necessarily induced. 19. 696 700 Such a phenomenon has the properties of a wave, and is naturally referred to as an electromagnetic wave. Electromagnetic waves were analyzed theoretically by James Clerk Maxwell in 1864. Maxwell developed a set of equations that could unambiguously describe the interrelationship between electric field, magnetic field, electric charge, and electric current. He could moreover prove that such a wave would necessarily travel at the speed of light, and thus light itself was a form of electromagnetic radiation. Maxwell's laws, which unify light, fields, and charge, are one of the great milestones of theoretical physics. 19. 696 700 Thus, the work of many researchers enabled the use of electronics to convert signals into high-frequency oscillating currents, and via suitably shaped conductors, electricity permits the transmission and reception of these signals via radio waves over very long distances. Production and uses. Generation and transmission. In the 6th century BC, the Greek philosopher Thales of Miletus experimented with amber rods, and these experiments were the first studies into the production of electrical energy. While this method, now known as the triboelectric effect, can lift light objects and generate sparks, it is extremely inefficient. 64. It was not until the invention of the voltaic pile in the 18th century that a viable source of electricity became available. The voltaic pile, and its modern descendant, the electrical battery, store energy chemically and make it available on demand in the form of electrical energy. 64. The battery is a versatile and very common power source which is ideally suited to many applications. But its energy storage is finite, and once discharged it must be disposed of or recharged. For large electrical demands, electrical energy must be generated and transmitted continuously over conductive transmission lines. Electrical power is usually generated by electromechanical generators driven by steam produced from fossil fuel combustion, or the heat released from nuclear reactions, or from other sources such as kinetic energy extracted from wind or flowing water. The modern steam turbine invented by Sir Charles Parsons in 1884 today generates about 80% of the electric power in the world using a variety of heat sources. Such generators bear no resemblance to Faraday's homopolar disk generator of 1831. But they still rely on this electromagnetic principle that a conductor linking a changing magnetic field induces a potential difference across its ends. 65. The invention in the late 19th century of the transformer meant that electrical power could be transmitted more efficiently at a higher voltage but lower current. Efficient. Early 20th century alternator made in Budapest, Hungary, in the power generating hall of a hydroelectric station, photographed by Prokudin Gorsky, 1905-1915. Electrical transmission meant in turn that electricity could be generated at centralized power stations where it benefited from economies of scale, and then dispatched relatively long distances to where it was needed. 66. 67. A wind farm of about a dozen three-bladed white wind turbines. Wind power is of increasing importance in many countries since electrical energy cannot easily be stored in quantities large enough to meet demands on a national scale. At all times exactly as much must be produced as is required. 66. This requires electricity utilities to make careful predictions of their electrical loads, and maintain constant coordination with their power stations. A certain amount of generation must always be held in reserve to cushion an electrical grid against inevitable disturbances and losses. Demand for electricity grows with great rapidity as a nation modernizes and its economy develops. 68. The United States showed a 12% increase in demand during each year of the first 3 decades of the 20th century. 69. A rate of growth that is now being experienced by emerging economies such as those of India or China. 70. 71. Historically, the growth rate for electricity demand has outstripped that for other forms of energy. 72. 16. Environmental concerns with electricity generation have led to an increased focus on generation from renewable sources, in particular from wind and solar. While debate can be expected to continue over the environmental impact of different means of electricity production, its final form is relatively clean. 72. 89. Applications. Electricity is a very convenient way to transfer energy, and it has been adapted to a huge and growing number of uses. 73. The invention of a practical incandescent light bulb in the 1870s led to lighting becoming one of the first publicly available applications of electrical power. Although electrification brought with it its own dangers, replacing the naked flames of gas lighting greatly reduced fire hazards within homes and factories. 74. Public utilities were set up in many cities targeting the burgeoning market for electrical lighting. In the late 20th century and in modern times, the trend has started to flow in the direction of deregulation in the electrical power sector. 75. The resistive Joule heating effect employed in filament light bulbs also sees more direct use in electric heating. While this is versatile and controllable, it can be seen as wasteful, since most electrical generation has already required the production of heat at a power station. 76. A number of countries, such as Denmark, have issued legislation restricting or banning the use of resistive electric heating in new buildings. 77. Electricity is however still a highly practical energy source for heating and refrigeration. 78. With air. The light bulb, an early application of electricity, operates by Joule heating, the passage of current through resistance generating heat conditioning /heat pumps, representing a growing sector for electricity demand for heating and cooling, the effects of which electricity utilities are increasingly obliged to accommodate. 79. Electricity is used within telecommunications, and indeed the electrical telegraph, demonstrated commercially in 1837 by Cook and Wheatstone, was one of its earliest applications. With the construction of first transcontinental, and then transatlantic, telegraph systems in the 1860s, electricity had enabled communications in minutes across the globe. Optical fiber and satellite communication have taken a share of the market for communications systems, but electricity can be expected to remain an essential part of the process. The effects of electromagnetism are most visibly employed in the electric motor, which provides a clean and efficient means of motive power. A stationary motor such as a winch is easily provided with a supply of power, but a motor that moves with its application, such as an electric vehicle, is obliged to either carry along a power source such as a battery, or to collect current from a sliding contact such as a pantograph. Electrically powered vehicles are used in public transportation, such as electric buses and trains, 80, and an increasing number of battery-powered electric cars in private ownership. Electronic devices make use of the transistor, perhaps one of the most important inventions of the 20th century, 81, and a fundamental building block of all modern circuitry. A modern integrated circuit may contain many billions of miniaturized transistors in a region only a few centimeters square. 82. Electricity and the natural world. Physiological effects. A voltage applied to a human body causes an electric current through the tissues, and although the relationship is nonlinear, the greater the voltage, the greater the current. 83. The threshold for perception varies with the supply frequency and with the path of the current, but is about 0.1 mA to 1 mA for mains frequency electricity, though a current as low as a microamp can be detected as an electrovibration effect under certain conditions. 84. If the current is sufficiently high, it will cause muscle contraction, fibrillation of heart, and tissue burns. 83. The lack of any visible sign that a conductor is electrified makes electricity a particular hazard. The pain caused by an electric shock can be intense, leading electricity at times to be employed as a method of torture. Death caused by an electric shock is referred to as electrocution. Electrocution is still the means of judicial execution in some jurisdictions, though its use has become rarer in recent times. 85. Electrical phenomena in nature. Electricity is not a human invention, and may be observed in several forms in nature, a prominent manifestation of which is lightning. Many interactions familiar at the macroscopic level, such as touch, friction or chemical bonding, are due to interactions between electric fields on the atomic scale. The Earth's magnetic field is thought to arise from a natural dynamo of circulating currents in the planet's core. 86. The electric eel, Electrophorus electricus. Certain crystals, such as quartz, or even sugar, generate a potential difference across their faces when subjected to external pressure. 87. This phenomenon is known as piezoelectricity, from Greek piezein, meaning to press, and was discovered in 1880 by Pierre and Jacques Curie. The effect is reciprocal, and when a piezoelectric material is subjected to an electric field, a small change in physical dimensions takes place. 87. Bioelectrogenesis in microbial life is a prominent phenomenon in soils and sediment ecology resulting from anaerobic respiration. The microbial fuel cell mimics this ubiquitous natural phenomenon. Some organisms, such as sharks, are able to detect and respond to changes in electric fields, an ability known as electroreception. 88, while others, termed electrogenic, are able to generate voltages themselves to serve as a predatory or defensive weapon. 3. The order Gemmotiforms, of which the best known example is the electric eel, detect or stun their prey via high voltages generated from modified muscle cells called electrocytes. 3. 4. All animals transmit information along their cell membranes with voltage pulses called action potentials, whose functions include communication by the nervous system between neurons and muscles. 89. An electric shock stimulates the system, and causes muscles to contract. 90. Action potentials are also responsible for coordinating activities in certain plants. 89. Cultural perception. In 1850, William Gladstone asked the scientist Michael Faraday why electricity was valuable. Faraday answered, "One day, sir, you may tax it." 91. In the 19th and early 20th century, electricity was not part of the everyday life of many people, even in the industrialized Western world. The popular culture of the time accordingly often depicted it as a mysterious quasi-magical force that can slay the living, revive the dead or otherwise bend the laws of nature. 92. His attitude began with the 1771 experiments of Luigi Galvani, in which the legs of dead frogs were shown to twitch on application of animal electricity. Revitalization or resuscitation of apparently dead or drowned persons was reported in the medical literature shortly after Galvani's work. These results were known to Mary Shelley when she authored Frankenstein, 1819, although she does not name the method of revitalization of the monster. The revitalization of monsters with electricity later became a stock theme in horror films. As the public familiarized